We all know now for a fact that we are made of atoms. It's not really a surprise anymore. But have you ever wondered what those atoms might look like? Are we made of puzzles? Marbles? A bunch of hexahedron building blocks like Minecraft? This conversation started a long time ago, all the way back to ancient Greece. People were still going on about Aristotle and what the four elements were. At the time, Aristotle was so super powerful that everybody else was silenced, including the father of modern science, Democritus of Abdera. This man is the first man to think of atoms. He thought maybe the world is made of a bunch of marbles. He thought of these small particles called atomos, Greek for atoms, which are indestructible and indivisible. This was the start of the atomic theory, which gave him his title. The theory was passed on down to the physicist John Dalton. He agreed to Democritus that the world is made of particle marbles. At the time, he thought that atoms looked like spheres, giving the model the name billiard ball model. He came up with the first basic rules about atoms in 1808 in his book, New System of Chemical Philosophy. It's made of 4 basic rules we call Dalton's atomic theory. 1. The world is made of indestructible pieces called atoms. 2. The same atoms have the same size, mass, and characteristics, and different atoms have different sizes, masses, and characteristics. 3. In a chemical change, atoms only rearrange. They do not change into different atoms, create atoms, or destroy atoms. 4. Chemical compounds are made in simple whole number ratios of atoms of each element. Of course, today, almost all of these rules have been proven false. That's how we found out how atoms look like. Scientists did continuous experiments until they find something that proved the previous scientists were wrong. Poor scientists. The first rule was proven wrong when protons, neutrons, and electrons were discovered. The second one was broken when isotopes were discovered. The third one was broken when nuclear reactions managed to create elements. The fourth was broken by another French chemist, Joseph Louis Gay-Lussac's experiment with water and hydrogen chloride, but an Italian chemist, Amedeo Avogadro, improved the fourth law to fit the experiment. The next physicist who challenged Dalton's theory was J.J. Thomson. During an experiment with a cathode ray tube sometime between 1898 and 1903, he found out that in a vacuum tube, if high voltages are applied, there are rays appearing inside the tube, this called cathode rays. Through this, he discovered the existence of electrons, negatively charged particles which formed atoms. Cathode rays were the shape of flowing electrons. At this point, Thomson changed the shape of the atom from marbles to electron pudding. He thought that atoms looked like balls with electrons in them, like bits in yogurt. In fact, his model was called the plum pudding model because of this shape. Atom model number 3 was brought by Ernest Rutherford in 1911. In the 19th century, scientists were starting to learn that certain elements gave out radiation, such as uranium. The radiation was mainly formed of gamma radiation, alpha particles, and beta particles. Out of those, Rutherford took the alpha particles and shot a ray through a very thin sheet of gold foil. If atoms were only made of electrons, which are negative, the particles, which are positive, should have went in a straight line. Instead, some of them spread out. This was the discovery of positive particles in the atom, which brought the idea of a nucleus inside an atom. Here, the planetary model of the atom was made, where there was a positive nucleus and negative electrons going around the nucleus like in orbit. The problem came when the planetary model said that hydrogen can only be stable for 10 to the minus 12th power seconds because of the electromagnetic waves, which is contradictory to the fact that hydrogen was always stable 24/7. So the next scientist to challenge the atoms came up, and that was the Danish physicist Niels Bohr. He thought of the electrons having certain energy levels in different electron shells. So basically he was saying that there were different levels where the electrons orbited that covered the nucleus in layers, like onions. This was just called the Rutherford-Bohr model. There isn't a fancy name for this one. The fifth and currently used atom model is the electron cloud, or the orbital as it is more widely known. When German physicist Werner Heisenberg came up with the indeterminacy principle, a law which stated that you can never locate and calculate the energy of an electron at the same time, Austrian professor Erwin Schrödinger created the wave function to locate the approximate probability of where the electron would be. This, when graphed on a 3D platform, showed the shape of a sphere, giving it the name of orbitals. It showed an electron cloud of where the electron would most likely be located. This is, as far as we can tell, what an atom looks like.